Okay, this topic here is in statistics, class of 2014, the new math studies syllabus. It's normal distribution. If you're in 2000, class of 2013, do not worry about this. If you want to learn it, watch along. But this, you just had your exams yesterday, so I don't even worry about it. Okay, so normal distribution. Normal distribution is basically what we would normally refer to as a bell curve here. This is what the IB syllabus says, what they want you to know. Students should be aware that approximately 68% of the data lies between the mean and one standard deviation. That M there is the mean. So what happens is the mean goes in the middle right here, and it's the Greek mu, like that. And then you know, this would be plus one standard deviation here. This would be minus one standard deviation here. And that's plus one, that's minus one. So they're basically saying that this is about 68% of the data. It's the area under the curve. Okay, so basically what this is you'll have a bunch of data, and most data, like IQ scores, test scores, stuff like that, fall into a normal distribution like this. Okay. Now, when you go two standard deviations, when you're up here, which would be plus two standard deviations, and down here, which would be minus two standard deviation. My Greek letters are not very good. Okay, I was in a fraternity in college too, believe it or not. I used to know all those. Okay, that was 90. That would be 95%, and then good old delta kappa epsilon. All right, and then let's see, three standard deviations, so minus three standard deviations and plus three standard deviations. That whole area, the green whole area, encompasses about 99% of the data. Okay, so what we're going to do is we're just going to be able to find percentages of basically and probabilities of where the data fits. Okay, so the best way to do this is just to go through some problems. Okay, now I drew that nice thing, but here it's even nicer. And you can see it right there. Okay, and it says the normal distribution is the most important continuous distribution in statistics. I didn't say that. Whoa, bell-shaped curve. I said that. It's symmetrical around the mean. Okay, so you have the mean in the middle, and then it's plus one standard deviation, minus one standard deviation, etc. The x-axis is an asymptote, so these lines technically never touch zero. The total area under the curve is 100%. 50% to the left of the mean, 50% of the right. Well, that makes sense, doesn't it? That right here, right here would be 50%, and over here would be 50%. Okay, and approximately 68% is within one standard deviation, 95 within two, 99 within three. Okay, no problem. I'm going to show you how to do this all on the calculator. It's pretty straightforward. It says the waiting times for an elevator are normally distributed with they have to give you the mean and the standard deviations on these problems. In standard level, there's problems where they don't, but they will here in studies, okay? So the waiting times for an elevator are normally distributed with a mean of 1.5 minutes and a standard deviation of 20 seconds. Sketch a normal distribution diagram to illustrate this information clearly in mean and the times within 1, 2, 3 standard deviations. Okay, fine. No problem. We can do that. Okay, so first thing I'm going to do is I'm going to draw a curve. And as we all know, my drawings are horrible, so bear with me. Now, the mean here is, now they say 1.5 minutes, but this is 20 seconds, the standard deviation. So I'm just going to change this to seconds. 90 minutes would be, 1.5 minutes would be 90 seconds. So I'm going to start my mean of 90 seconds. So that's my mean. That always goes in the middle. Okay, now let's do the first standard deviation. Okay, first standard deviation would be here and here. Now, since it's 20, here we just do 90 plus 20, which would be, 110, and then 90 minus 20, which would be 70. Okay? And then, you do the same thing you just keep adding on. So for the second standard deviation, we're going to add 20 more, so that'd be 130, and subtract 20 more, which would be 50. Okay? And then, And then for the last standard deviation, we're going to get 30 and 150. Okay, so that's 3 standard deviations. Ugly, 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 but you get the point here. Okay, so find the probability that a person waits longer than 2 minutes and 10 seconds for the elevator. 2 minutes and 10 seconds. Well, 2 minutes is 120 seconds, so that they're saying 130 seconds. So they're saying greater than 130 seconds. Okay, now we can look here. We can count all this stuff under here, standard deviation if we want, but there's an easier way to do this, and let's just go straight to the calculator. Okay, and the calculator again is your friend on these types of problems. I'll just stick it right there. Okay, so turn it on, go to second distribution, and you go to the second one, normal CDF. Okay, now the lower bound, what they're saying is they want greater than 130. So the lower bound is actually going to be 130. Okay, so we'll put that here. And the upper bound, now it never quite goes to 0, so we just want to pick a really big number. So I would just do 1 second e to the 99th power. Okay, it's just something you have to memorize. Okay, when it came up, you'll notice it was -1 e to the 99. I'm just making it really, really close, really, really big number. Yeah, whatever. Okay. Now they give us, this is the mean right here. So the mean was 90, and the standard deviation is 20. So once we get all that, we just press enter, and it's point. What do they want? Find the probability that waits longer than 2 minutes and 10 seconds. So it's 0.0228. to 3 significant figures. So the probability here is 0.0228. Okay, which that makes sense because this is going to be a really small area, right? Or well, actually, right here. That's the area we're talking about. Look at all this. It's all 100%, but this is pretty small. Okay. Now find the probability that a person waits less than 110. Okay. Well, that's 70. So that's right here. Okay. So in this case, for part so here, sorry. Let me get, okay, so B would be 0.00 or 0.228. Wow, that's just horrible. Let's erase that. Okay. 0.228, and then let's do C. Now C, they're saying less than basically 70 seconds, so they're talking about this area right in here. Okay, again, we just go to a calculator. And I normally clear this off and just go second distribution, normal CDF. Okay, now I want to put my upper bound here happens to be the 70. Now for my lower bound, I'm just going to put a really small number. So I'm going to put -1 second e to the 99th power. And I still have 90 and 20. And I get 0.159. So 0.159. So 0.159. So this area under the curve is, roughly, 15.9%. This area on the first problem was roughly like 2.28%. That's what we're finding. We're finding, the probabilities here. Okay. Now, it says 200 people are observed, and the length of time they wait for an elevator is noted. Calculate the number of people expected to wait less than 50 seconds. Okay. Well, again, for this, we just have to find. Whoa. God, I keep hitting that. Sorry. Again, I'll just go, okay, second distribution, normal. And I've got that good. Now, my upper bound here, again, is going to be 50. That's going to be a pretty small number. Okay, so everything's the same. The mean is 90. Standard deviation is 20. So it's 0.00 or 0.022785, whatever. Okay, but they want the expected value. Okay, so in order to find the expected value, all you have to do is multiply by the number of things or people or whatever it is. In this case, it's 200 people. So this basically says 2.28%, and so there's 200 people, so we're going to multiply by 200. Bam! So 4.55. So you can't have 4.55 people, so what I would basically say is I would round it up and say 5 people. And you're pretty much good to go on that. Okay, so let's try another problem here just to make sure we got this down. The heights of 250 20-year-old women are normally distributed with a mean of 1.68 meters. Okay, no problem. And a standard deviation of 0.06 meters. Okay. Okay, that's not bad. No, it's still horrible. Okay, sketch the normal distribution diagram to illustrate the information, clearly illustrating the mean. Okay, the mean, they said, was 1.68. Okay. Now, the first standard deviation, you're just going to add 0.06, so that would be 1.74. And then, the second one would be 1.80, and then it would be 1.86. Now, they don't always ask you to do this, but it's kind of nice just to look at the graph. So now you subtract 0.06, so it'd be 1.62, 1.56, 1.48. Now, this one, it says find the probability between 1.56 and 1.74. Okay, so 1.56 and 1.74. So what they want is this area right in here. Now, the calculator is going to give us an exact value. You can do this by percentages, but I don't agree with that. So I just want to go straight to the calculator and go normal. Okay, now in this case, we don't have to put a high or a low number because they give us the boundary. So the lower boundary is 1.56. The upper boundary is 1.74. And what's the mean? Okay, 1.68 and 0.06. Okay, boom, boom. 0.819. So the probability that the height is between 1.56 and 1.74 is 0.819. Okay, so that's quite a bit. That's 81%. Okay, find the expected number with the height greater than 1.8 meters. Okay, fine. No problem. We need to find the probability first. So we'll just clear. We go to second, distribute, normal CDF. Okay, they give us a lower bound because they want greater than. So it's 1.8. And then we'll just put a really high number here, like 1e to the 99. We already have our mean and standard deviation, so we're good. It's 0.0222. You're seeing that number quite a bit. 0.022750062. Okay, fine. And there's 250 of them, so we'll just multiply by 250. Boom. We get 5.68. So I would say 6 women are greater than 1.8 meters. Okay. All right. So that's pretty much that for finding the probabilities and expected value. It's pretty straightforward. Now, there's the last thing we need to do here is what's called the inverse normal, where they actually want you to find the numbers after they give you the probabilities and stuff. Okay, so we'll do that right now. Okay, so for inverse normal calculations, sometimes you're given the percentage area under the curve, i.e. the probability or proportion, and asked to find the value corresponding to it. This is called an inverse normal. Okay, always make a sketch to illustrate it. You must always remember to use the area to the left when using your GGC. This is really, 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 really important. You always want the area to the left of whatever they're asking. If you're given the area to the right, you must subtract this from 1 before using your GGC. Okay, so like let's say they gave you one of these, and let's just say in this case, the question says 5% are greater than X. Well, you would have to do 1 minus 5 to get 95. Okay, so for an example, an area of 5% above a certain value means that there's an area of 95% below it. And I think that makes sense. Now, this is really good right here. In examinations, inverse normal questions will not involve finding the mean or standard deviation. That's good. So that means they have to give them to you, okay? And that's in standard level, you have to find them. It's not a hard formula, but it can get a little tricky. You have to find these things called z values and all this, but we don't have to do that. So let's try a couple problems. This is whatever. We'll do it. Here we go. Okay, so for this problem, it says the volumes of cartons of milk are normally distributed with a mean of 995 milliliters and a standard deviation of 5 milliliters. Okay, so 995 is right here. Okay, I'm just drawing a diagram to see, so you can see how it looks. It is known that 10% have a volume of less than X. Okay, so what they're saying is that there's something right here, X, where, you know, that 10% have a volume of that. So they want to find X. Okay, now there's a very specific way to do this. Okay, you turn on your calculator, you clear it all out, and you go to second distribution. And instead of, anytime you're finding the X, instead of going to normal CDF, you go to inverse normal. Okay, now the area they say is 10%. Well, we need to put that as a decimal, so you just put 0.1. If you put 10, that you can't do that because the area only goes up to 1. Okay, now they give us the standard or the mean, which is 995. The standard deviation is 5. Okay, so we just go like that, and it is 989 to 3 significant figures. Okay, so this X right here is 989 milliliters. So what they're saying is that 10% of the milk is less than 989 milliliters. Okay, that's good. We're good to go. I mean, see how straightforward that is? Let's do one that's a little trickier. Okay, so this last problem kind of combines everything, which is nice. Okay, so this sums it up pretty well. Okay, the weights of pears are normally distributed with a mean of 110 grams, standard deviation of 8 grams. Okay, so again, it's nice to draw just to get an idea. Okay, I'm sure your drawing will be better than mine, as always. Okay, so the mean, they say, is what, 110. Standard deviation is 8. So the first one standard deviation would be 118. This would be 102, etc. as you go up. Okay. So A, it says find the percentage of pears that weigh between 100 and 130. Okay, so if we're ever finding percentage or probability, same thing really, we use the first one. This is like the first types of problems we did. So we just go boom. Now they give us a range here. The lower is 100, the upper is 130. Now what's the 110 is the mean, and 8 is the standard deviation. Boom, boom, boom. Oh, 0.888. Okay, so the percentage of pears. Now they want it in percent, so we just need to multiply that by 100 to get the percent. 88.8%. Okay, so in this case it's 88.8%. Okay, so that's quite a few. Okay. All right. So now this is the only type that's even a little bit tricky on these. Okay. It is known that 8% weigh more than m grams. Okay. So what they're saying is that there's a value of like m that's, say, right here. Okay. And let me use a different color. That's not good. Okay. So right here, m, and that 8% weigh more. So 8%. Now remember, when we're calculating inverse normal, we're finding m or x or whatever. So we have to use the area to the left of the curve. So I'm going to do, 100 minus 8, and that's 92%. Okay, or 0.92. Okay. Now once we have that, we're ready to go. Okay. So just be careful. Anytime it says weigh more than, you have to subtract. Okay, so let's bring that up and go. Okay, let's go second distribution. Now we're finding m or x or whatever, so we go inverse normal. The area is 0.92. Mean was what? 110, and standard deviation was 8. Boom, boom, 121.2. So this is 121. Okay, and it is grams. Always put your label. Okay, I did it to 3 significant figures. Okay, and then finally the last one. This is expected value. Another thing you have to be able to figure out. 250 or weigh. Calculate the number that weigh less than 105. Okay, well fine, no problem. So let's go back. Clear. we need to find a probability. So we go second distribution, and we go to the second one. We're not finding x. Okay, now they give us the upper bound. It's 105. So the calculator defaults to this, so we're good to go there. A really small number. And then 110 and h, boom, 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 is 0.265, blah, 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 blah. Okay, now, how many are there? There's 250 of them, so we'll just multiply by 250, and it is 66.5. So, you know, I would say 66 or 67 pairs. Okay, you're never going to have a 0.5 pair. Well, I guess you could in real world. If someone took a bite out of it, like when you're in the teacher's lounge and you put a sandwich in and someone takes a bite out of it. Anyway, okay, so it didn't happen to me. It happened to one of my colleagues. It was gross. Okay, so anyway, this is normal distribution. So I don't know. It's kind of a long slog here, but it took me a while, but I think we got through everything. Normal distribution, concept of a random variable, parameters of mean, standard deviation, symmetry, okay. Normal probability calculations, expected values, inverse normal calculations, check, check, check. Not required, okay. We don't have to transform them. You don't have to find z. You don't have to find mean or standard deviation. You don't have to use z. Boom, boom, boom. You could use this in your IA, but whatever. Expected to use the GDC. We use the GDC. Check. Sketches normal curves. Mine suck. Check. All that. Check. Okay, we're good. All right. So one last thing I want to leave with you. Leave you with. You may have seen this in the last. This is one of the coolest things I've seen. All right. Hold on just a second. All right, if you didn't hear about this story, it was trending on Twitter. It's an amazing story about well, it's a horrible story that these women were kidnapped, but this guy right here, he gave an awesome interview. So I'm going to link to this interview just at the end of this, just because I think it's pretty funny. And there you go. Have a wonderful day.